We are going to jump ahead to Module 13, and the first section is talking about measures of center and spread. So the two measures of center are mean and median. The mean is the average, where we add up all the numbers and divide by how many there are in the set. And then median is, after we put them in order from smallest to largest, we find the middle value. If there is an even number of numbers in the list, then we have to find the average of the two middle numbers. So we add those two together and divide by 2. So for example 1, it says find the mean and median for the set of values, and these are the amounts of money that Elise earns in tips per day for 6 days. So we have to start off with the mean, and that means we have to add up all of those numbers. There's 6 of them there. And when we add them all up, we get 835. So we have to divide that by 6. And that gives us 139.17. It is 0.16 repeating, but we're talking about money, so we rounded to the nearest cent. So that's the mean. The median, we have to put them in order from smallest to largest. And then cross off one from the front, one from the back, one from the front, one from the back. And then that's where we have 2 numbers left. So the median is actually between those 2. So sometimes you can look and tell what they are and figure it out, and other times you can't. So if you can't, you add those 2 numbers together. So 97 plus 100 is 197, and then you divide by 2. And in this case, we get 98.5. And since we're talking about money, we have to put that 0 on the end. So the median amount of tips she gets is $98.50. Now we're moving into the measures of spread. We have a few of those here. The first one is range, and that we just take the largest number and subtract the smallest number. Then we have quartiles. Quartiles are dividing that data set into 4 equal parts. So we have the first quartile, and then we have the median, and then we have the third quartile. And once we find those 3 things, we have 4 different sections in our list of numbers. So the first quartile is the middle number or median of our lower half. So we have to find the median, and then we can find the middle of the front half of numbers. And then the third quartile is, after the median is found, we take the list that's left in the back, and find the middle of that list. And then interquartile range is where we take quartile 3 and subtract quartile 1 from it, and that represents the middle half of the data. So 50% of the data is in that range. So for example 2, the April high temperatures for 5 years in Boston are given. We have to find the median, the range, and the interquartile range for this set. So for the median, we have to put the numbers in order. And cross off one from the front, one from the back, one from the front, one from the back. And we have one number in the middle, so that's 86. Then we find the range, and that's where we take the large number and subtract the smallest number. And 93 minus 77 is 16. And then we find the interquartile range. So we've already put them in order. We found the median, so now we have to find the middle of the front half. Well, there's only 2 numbers, so we have to figure out what's between 77 and 84. So I'm going to add those 2 numbers together, and I get 161, and divide it by 2. So the first quartile is 80.5. And then for the third quartile, I have to figure out what's between 90 and 93. And so we add them together, and we get 183, and we divide that by 2, and we get 91.5. And then we subtract those. So 91.5 minus 80.5. And we get an answer of 11 for the interquartile range. Now, still working with the measures of spread, we're going to talk about standard deviation. So the formula for standard deviation here is given. So we can plug in everything we know here, or we can go through step by step and figure it out a little bit easier. So the X with the line over it is the average, the mean of your set of data. And N is how many numbers are in that list. So um, when we break it down, it's a whole lot easier than looking at this formula, but that's what the formula looks like. So example 3 is asking us to calculate the standard deviation for the temperature data from example 2. And standard deviation is just another measure of spread, and it represents the square root of the average of the squared differences between individual data values and the mean. So it's the average of the average, basically. So we're using the values from example 2. So those numbers were 77, 86, 84, 93, and 90. And the first step is to calculate the mean. So if I add those all up, I get 430. And then I divide by 5, because there's 5 numbers. So our mean is 86. So then for step 2, we take the list, the numbers that are in our list, and then we subtract the mean from them. So this one, we're going to do 77 minus 86. That would give us -9. This one, we're going to take the value 86 and subtract 86, so we would get 0. And this one, we're going to take 84 and subtract our mean, so we would get -2. So how far away from the average are these numbers? So 93 minus 86 is 7. 90 minus 86 is 4. Then once we find those 5 numbers, we square them. So -9 squared is 81. 0 squared would be 0. -2 squared is 4. 7 squared is 49. And 4 squared is 16. So notice I put parentheses around the negatives because if you don't do that, if you're going to use a calculator and you don't do that, you're not going to get the right answer. So it's -9 times -9. If you just type it in without the parentheses, it's going to assume that's a -1 out front, and you're going to have a negative answer, which is not correct. All right, once we find those 5 numbers, we're going to find the mean of them. So we're going to add up 81, 0, 4, 49, and 16. And when I add those all up, I get 150. And I have to divide by how many there are, and there's 6 of them. Oh, there's 5 of them. And 150 divided by 5 is 30. And then step 4 is to take the square root. So square root of 30. And we use a calculator, and we round to the nearest tenth, it says in the directions. So this is about 5.5. So the standard deviation is about 5.5. So the smaller the number that we find for standard deviation, that tells us that the numbers in our list are closer to the average, so they're not as spread out. So if that number is larger, then our numbers are farther away from our average. Now, moving on here with statistics, those are numbers that are characterized by a data set. We're going to look at these football teams, these NFL players and their ages, and MLB players and their ages. And we're going to use the graphing calculator to help us find these. So this part we're going to do in class together.